All right, you did it. You've made it to the last section in Chapter 2. This college algebra thing might actually happen. I think you got this. Let's have a look at the distance and midpoint formulas and the equation of a circle. As it says in the title of this section, we're pretty much looking at these three subtopics, and they are easy, easy, and easy. They're also pretty easy to deal with, and then kind of a pain to deal with. But I'm going to walk you through all three of them. Let's see what we've got. The distance formula. So we're going to be finding the distance between 2 points, x1, y1, and x2, y2. Here is an illustration of how it is that we're finding the distance between those 2 points. If we plotted the, wow, there's some really high-res graphics in this image. Yikes. If we plotted the 2 points, point 1 and point 2, with those x coordinates, we could figure out the distance between their x values, the distance between the y values, and then basically what we're doing is we're creating a triangle. You can see the triangle there that's been created. More super awesome graphics. And the distance between the 2 points is the hypotenuse of a right triangle. So if we can figure out the base of the triangle in the x direction and the height of the triangle in the y direction, then all we have to do is use the Pythagorean theorem in order to find the distance between our 2 points, because that distance will be the hypotenuse of the triangle. And so here's the Pythagorean theorem. This is a squared plus b squared equals c squared. But we don't want to know what c squared is, we want to know what c is, so we're taking the square root of both sides of that equation. We don't care about the plus or minus because nobody wants to know about a negative distance between 2 points, so we're just going to use the positive version of that. That's the distance formula. Told you it was going to be easy. Let's see, is there excuse me, an example problem that we want to work on? There is an example problem. We don't want to work on it. Let's do it anyway. The distance is equal to the square root of, I'll make that square root symbol larger in a moment. We need the difference between our x values, which I'll use, let's actually label these. Let's have this be x1, y1, and x2, y2. So the difference between our x values is -1 minus +2, and we're going to square that, and then we're going to add to it the difference between our y values. y2 is a 5 minus y1 is a 2. Now if there were a double negative in here, for example, if this said -2, then this would have to say minus, and then maybe you would put the -2 in parentheses or something and then square it. So just make sure that you're using extra care if you end up needing to subtract a negative number. We're going to square that. We'll put the square root symbol over the whole thing, and then it's arithmetic, which is great because we know how to do that. This is the square root of -1 minus 2 is -3 squared is 9. 5 minus 2 is 3 squared is 9, so we've got the square root of 18, which gives us the opportunity to review simplifying a radical. The square root of 18 can be broken down into the square root of 9 times the square root of 2. We could have also turned it into the square root of 6 times the square root of 3, but I don't know the square root of 6 and I don't know the square root of 3, so why would I do that? I much prefer 9 and 2 because at least I know that the square root of 9 is equal to 3. We're stuck with the square root of 2, so we've got to keep that, and this is the distance between our 2 points, 3 root 2. The midpoint is so fantastically simple, it's almost upsetting. In order to find the midpoint between 2 points, x1, y1, and x2, y2, you need to average their x coordinates and average their y coordinates. Yes, I get paid to do this. Isn't this nice? You should be so lucky. Thankfully, these fill-in-the-blank notes are very well organized, and even though they're a little low-res sometimes, the information in these is very well organized. We've got some nice examples that we can look at. So let's just go ahead and humor our fill-in-the-blank notes and average a couple of numbers. We've got -2 plus -8 divided by 2, comma, -1 plus a +6 divided by 2. Those are the coordinates of the midpoint. All we have to do is clean it up. -2 minus 8 is -10 divided by 2 is -5. -1 plus 6 is +5 divided by 2. We can't simplify that, so you've got a y value that's an improper fraction, 5/2. I don't recommend typing it in as 2.5. I would type this in as 5/2 or maybe 2.5. That should work. But if you're typing this into online software, 2.5 can get a little dicey because sometimes the computer thinks that it's 2 times 1/2. So again, my recommendation is an improper fraction or a decimal. And that's how you use the midpoint formula. Average the x values, average the y values. Now it's interesting, a little bit, that circles are part of this conversation also. A circle, the key sort of elements that we're going to look at on the circle are the fact that a circle has a center point and a circle has a radius, and you know that the distance from the center to any point on the circle is a consistent distance, and that distance is called the radius. So what we're going to do is we're going to fix a point to be the center of our circle. That's going to be HK, and H and K are fixed values. Okay, we just don't know what they are, but they are fixed values. And this point out here, x comma y, is something of a variable. That point could move around and occur anywhere on this circle, but the distance from the center to that point and any point on the circle is equal to r. And let's see if we have we don't. If we drew in our right triangle here, right? There it is. Now the radius is the hypotenuse of that right triangle that I just created. And we could find r. It's the difference in our x values squared plus the difference in our y values squared would equal r squared. It's the distance formula. And here it is. And then if we took the square root of both sides, we wouldn't have r squared over here, but we just have r. But if you take the square root of the right-hand side, you have to take the square root of the left-hand side, so that's why you're seeing a square root symbol there. This is the formula for a circle. It's the Pythagorean theorem, again, which is the distance formula, which is the formula for a circle. I feel like I'm letting you down. It's like a 3-for-1. I just keep delivering you the same news and repackaging it. Now, instead of having taken the square root of both sides like we did in the distance formula, if we sort of back up one step, this is what the second to last line in the distance formula conversation looked like. Let's just go up there and see it. There it is. Here it is with the square rooting already being done, but here's that second to last stage before we did the square root. All you do is replace this with an r, and this, I think this one was the h and this one was the k. Doesn't really matter actually. And all of a sudden you've got the formula for a circle. All right, let's get back down to our circle. There it is. That's the standard form for the equation of a circle. Would anyone ever multiply this out, like foil this and combine like terms, and that? Yeah, somebody did that. And then that same not nice person hands you that mess, and they're going to ask you to recreate it and make it look nice and organized like this. That's the, oh boy. That's the third thing that I said was going to be really irritating. Yeah, we're going to have to do that. But not yet. Write the standard form of the equation of the circle with center 2, -1, radius 4. Great. This is h comma k, and this is r. I know that because it says r equals 4. I'm going to take these two values, the h, and I'm going to plug it in here, and the k, and I'm going to plug it in here, and the r, and I'm going to plug it in here, and I'm going to have my answer. This is the last section of the chapter. Isn't that amazing? This is too easy. You're just waiting for the other shoe to drop, and you keep waiting because it's going to drop in a second. All right, so we've got x minus, now my h value is a positive 2, so that goes in nice and easy, plus y minus, now my k value is a -1. So there's an example of that double negative that you got to watch out for. Squared equals, well, why not? We'll write it as 4 squared so that we can go through it one more time. So this equation, we'll clean it up, put a little note here if you want simplify or something like that. And we'll get our final answer as x minus 2 squared plus y plus 1, quantity squared, equals 16. And this is it. That's the equation for your circle in standard form. Now let's kind of work this backwards. What is, so how could I do this? How big can this pen get? Oh yeah, perfect. Great. Looking at this equation, I want you to tell me what are the coordinates of the center of the circle. It's a little tricky because this almost looks like the x coordinate for the center of the circle should be -2, and it's not. It's positive 2. That's because what this says right here is x minus positive 2. So that's your h value. And remember, this does not say y plus 1. This says y minus -1 squared. So if we use the same sort of rhythm to analyze this, it says y minus k. So your k value is a -1. So again, this is a positive 2 and this is a -1, but let's be careful because this sure looks like it's a -2, but it's not, and it sure looks like that's a positive 1, but it's not. So they're kind of the opposite of what you might think. And remember that this is not your radius, this is r squared. So if someone says, what's the radius of this circle, you've got to square root the right-hand side. Now what if this wasn't a 16? What if this said 17 over here? Is it possible that the radius of my circle could be the square root of 17? Absolutely. What if it was 18? The radius could be the square root of 18? Sure could. This could equal 18, and if you have to square root both sides, r would equal the square root of 18, which is the square root of 9 times the square root of 2, which is equal to 3 root 2. That's an acceptable radius. Okay, so you could run into that. Most importantly, I think the biggest danger here is remember that these are kind of opposite of what you might think they are at a first glance, and remember that your r value is the square root of that number. Okay, so that's a little bit irritating, but I can still handle that. I don't know if I can handle the sound of my cat meowing outside the door. Let's be patient, maybe she'll go away. Oh, here we go, question number 4. Give the center and radius of the circle. Remember, it's the opposite of what this looks like. The h value here is a -2, and it's the opposite of this. So your k value is actually a positive 3, and your r value is the square root of 25. 25 is r squared, so your r value is actually 5. So you have -2, 3 with an r value of 25, -2, 3, 5. There it is, option A. Love that. All right, so again, be careful, watch out. You got opposites on those h and k values. And then here's that not nice person I was telling you about. I'm trying to be as politically correct as possible. They went and they foiled it and they combined like terms and they organized all the things. Look how nice that was. They put the squares first, and then they put the x to the first power and the y to the first power. And the constant values are all together so that the right-hand side can be 0. It looks very tidy, but it's not very helpful when it comes time to try to find the coordinates of the center of the circle, or the radius. So how are we supposed to determine the center and the radius? We're going to do a process called completing the square. And we're actually going to do it twice in one problem. We're going to complete the square for the x values, or the x terms, and we're going to complete the square on y. And then I will show you how we end up with our constant value, or the radius squared. So the first thing I'm going to do is I'm going to write my x squared and my plus 12x, and then I'm going to add something. And then for my y values, I'll have plus my y squared and minus a 6y, and then I'm going to add a little something else. And then I'm going to add 4 to both sides of this equation so that this equals positive 4. Red. I don't like putting red next to green. It's too Christmassy. What about, let's do blue. There's the positive 4. Okay, now what numbers are supposed to go into these blanks that I left? I'll tell you how to create those numbers. I'm going to take the number 12, and I'm going to divide it by 2, which gives me a 6, and then I'm going to square it, and that's equal to 36. And that's the number that's going to go into that first blank, but don't write it in there yet. And then, over here, I'm going to take this number, the negative 6, and I'm going to divide it by 2, which is negative 3, and I'm going to square that, and I'm going to get 9. And that's what's going to go into my second blank. So let's rewrite this, but I forgot to do something. I always forget to do this. I would have remembered it later, but let's put a little note down right now. If I add something to the left-hand side of the equation, I must also, that's correct, I must also add it to the right-hand side. And if I add something else to the left-hand side, I must add it to the right-hand side. So don't forget to keep your equation balanced. All right, so now let's start adding those numbers in. So we've got x squared plus 12x plus 36 plus y squared minus 6y plus 9 equals the original 4 that we added to both sides of the equation plus the 36 that we added to the left, so we're adding it to the right, and plus the 9 that we added to the left-hand side. Great. Now, these first 3 terms here are x terms. We're going to factor those, which normally you might think this is going to turn into parentheses times parentheses. The good news is both of those parentheses are going to be identical to each other. And I know that because of the way that I engineered this. That number 36 works with the 12 in a very nice way. Check this out. When you factor it, you get x plus 6 times x plus 6, which I'm just going to write as x plus 6 squared. What's 6 times 6? That's the L in the foiling process. It's 36. And what's the O and the I terms in the foiling process? That's going to be a 6x plus 6x, which makes 12x. Isn't that nice? The fact that we got to write that as x plus 6 squared is why we called this part of the process completing the square. We did that, we created that 36 so that when we factored it, it would turn into a square. Same process for our next 3 terms. This is going to be y minus 3 squared. You could double check it and FOIL it out, combine like terms, you'll get y squared minus 6y plus 9. And on the right hand side of our equation, we do the addition and we get 49. That is in, this is general form. We just wrote our answer in standard form. Much nicer to work with. So writing the equation in standard form, and then let's do that little exercise again. I'll give you 15 seconds to, it's not even going to give you 15 seconds. Write down the coordinates of the center of this circle and write down the radius of this circle. Okay, you ready? The answer is, what is h comma k equals -6 comma +3 with a radius of 7? If you got -6, 3 and a radius of 7, you win whatever you want. I want you to have whatever you want. But at the very least, you get a point for getting this answer correct. Maybe 2 points. 1 for the equation, 1 for the center, another point for the radius. Why not? 3 points for everyone. And that, ladies and gentlemen, is our very last topic in Chapter 2. I hope going through these examples is helpful, gets you through the homework, and gets you an A on your next test. So corny. See you in Chapter 3. Thanks. I clicked stop. It's still recording. Okay, bye again.